Hello everybody, this is the fourth video clip for our chapter 1 of a Calculus for Business 2. Okay, previously what we have learned is about the homogeneous system, which is the matrix A multiplied by a variable matrix X equals to the all zero vector here. And if you reduced your A, okay, to be a reduced matrix, then this reduced matrix will indicate whether you are going to have a unique trivial solution, which is all the variables are equals to 0, or you may obtain the infinitely many solution, depends on this non-zero row of your reduced matrix and the number of variable, okay, here. But for this clip, we are going back to the non-homogeneous system that we usually will encounter more, okay. So a non-homogeneous system, it means that you have the coefficient matrix A multiplied by the variable X equals to a constant matrix B, and this B is not all zero matrix, okay. And if you go back to your high school, then you may think that, hey, if you got like a real number 2 multiplied by x equals to 5, then to solve for x, okay, it is just simple, like move your 2 instead of multiplication into a division. However, the way you move it like that, actually you has passed one process, is that as you have this equation, then you multiply this one by 1/2 and also on your right hand side by 1/2, and this 1/2 is called the inverse, okay, a multiplication inverse of a 2, so that if you got the inverse, okay, of your A multiplied with the A itself, it will go back to the identity, which is 1, okay. So and after you got the 1, your 1 multiplied by x becomes just x alone, so that's why you end up with x equals to 5/2, which is your solution for this equation in terms of real number, okay. However, in terms of matrix, okay, we don't have matrix division, or what we have is only a matrix multiplication. So we are dream of, like, can we multiply this one by the inverse of a matrix A, and also multiply this one on your right hand side by the inverse of a matrix A, so that the inverse and the A itself will kill each other to got into your identity. But right now the identity is the identity matrix I, okay. You remember the I, that is a square matrix with all diagonal element is 1, right, and then the other element outside the main diagonal, it is all 0, okay. And this I play the same role as your 1 in real number. So your matrix I, the identity, multiply with x, you got the x itself. So it means that if you can do it this way, then you can solve for your variable x immediately, okay. So today we are going to talk about the inverse of the matrix, okay. So however, in order to talk about the inverse, I mean, one of the most important thing is that you must talk about the inverse with a square matrix only. So first of all, your A must be a square matrix, okay. If there is a matrix C, okay, another matrix C, such that your C multiplied with A becomes the I, then your C is called the inverse of the A, okay, and your A is said to be invertible, or as usually we call it non-singular, okay. And if we talk about the invertible matrix, okay, we'll have one and only one inverse. So it means that your inverse, I mean, for 100 people finding the inverse of your matrix A, I mean, if it exists, then they're going to obtain the same inverse, okay. So this A inverse is unique. So by a uniqueness, then we can give them a notation. So the inverse of the A, it is denoted by A and superscript -1. So it is not a power, okay? This one is just a superscript, A superscript -1, or sometimes, I mean, as we read it as A inverse, okay? And the other thing that is important is that the multiplication between A and A inverse are commutative. That it means that you can change the order, okay, among these multiplication. You can do A and A inverse, or A inverse multiplied by A. It will go back to the same thing, which is the identity matrix I, okay? So let's talk about the inverse of a 2 by 2 matrices, okay? For example, if this one is your A, okay, and let's say that we are going to find the A inverse, okay? So let's just pretend that you don't see this. This is the A. So here is X, Y, Z, W, okay? So let's say that this one is your A inverse, and then you need it to be the I, okay? This is your I2, okay? So what does this mean? It means that as you do a multiplication, okay, don't forget that all these are given, okay? So think of it as numbers, but this one are all variable that you need to determine, okay? So this one, the first equation becomes AX and BZ equals to 1, okay? And the second equation, okay, so let me just do this one, okay? The second row multiply with the first column, because all these first column will depends on the X and the Z alone, right? So you got CX and DZ equals to the second row, the first column is this one, right? The second row, the first column will equals to 0. So it means that you have two variables, X and Z, you see, but your A, B, C, D, they are all numbers, okay? They are all numbers. So how we are going to get rid of, let's say if you need to get rid of the Z, okay, you are going to just multiply the whole thing by D, and you can multiply the whole thing there by B. So what you end up with is A dx and B dz equals to D, right? And this one you got CBX, let's do it this way, BCX and BDZ equals to 0, okay? So as you have the same coefficient of your Z here, you can do a subtraction, right? So what you end up with is AD minus BC, okay? This is all numbers multiplied by X equals to D minus 0, so you have a D. So it means that your X can be simply write in terms of fraction D over AD minus BC. However, it depends on your bottom as well, that your bottom must be non-zero number. So okay, in order to make it as a denominator, okay? So let's look at another two variables, y and w, okay? So let us do the first row multiplied by your second column, okay? So what you end up with will be A, Y, and BW equals to the first row and the second column, it is 0. And this one, the second row and your second column, you have CY and DW equals to 1 right here, okay? So again, can we just get rid of a W, okay? So if you want to get rid of a W, then you can multiply this first one by a D, and you multiply the second one by a B again. So by multiply with a D, what you end up with will be a dy and b dw equals to 0, and bcy plus BDW equals to B. Okay, and then let us just keep doing it as previously by, here they are the same coefficient of W, so we do a subtraction again. So we are going to have your AD minus BC with a Y equals to negative B. So it means that your Y, it is minus B over AD minus BC. You see, again, your bottom must be not 0. Okay. Actually, for the first part, okay, as you have your X, okay, I forgot to figure out for the Z. Okay, so as you got your X for the first part, okay, you can see that, hey, your Z can be calculated from here, right? Can you see? Here is your Z. Okay, so your Z from there, it is what? Let me put it down here. Your Z, it is negative Cx over D. You see, you just move your Cx over here and you move D to divide it. Okay, but what is your X? Your X, it is D over AD minus BC. Okay, so it means that your D actually cancelled, so you have your Z to be negative C over AD minus BC. Again, it depends on this one that is not a zero number. Okay, how about here on your second part, after you got your Y, so can you figure for your W? All right, so here your W becomes just simply the negative AY over B. Okay, so what you have here, your Y is this one, right? So as you plug in, the negative and the B cancelled, so the one that survive is your A on top. You see, so all what you have is your A over AD minus BC. Okay, so it means that if you talk about the inverse of this ABCD 2x2 matrix, your X is D over AD minus BC. Here's your X. Your Y is right there, minus B over AD minus BC. Okay, and your Z over here, it is negative C. Let me just elongate it. Negative C over AD minus BC. And your W is right there. It is A over AD minus BC. So each and every element in your, so this one can be your A inverse, right? Each and every element in your A inverse depends on these numbers, AD minus BC. And you know that this number, as it appears at the bottom of your fraction, it must be non-negative, right? So you are going to just pull it out, okay, so that you don't need to write 4 times. Okay, so you pull it out as a constant, as a scalar or a constant multiply outside, and then here it will be just your D, okay, appear, your negative B right there, your negative C right here, and your A just right there. So what is it that you do from your A? Okay, so it's look like you interchange the position between the element in a main diagonal, right? Your A and your D interchange, you see, and then you change the sign. Okay, you change the sign of your B and C. Okay, for your A it is a normal B and C, right? But for your A inverse, it is a negative B and a negative C. Okay, but keep it at the same position. Just change the sign. You see, the one that you usually forget is to multiply by this constant. Okay, so don't forget to multiply by 1 over AD minus BC. So of course, I mean, if your AD minus BC equals to 0, then the A inverse does not exist. Okay, you cannot find the A inverse, and then your A is called a singular. Okay, a singular. So there's no, there's no A inverse. So it is singular. There's no, mate. Okay, just like that, right? So for example, if you look at this one, okay, here's your A, B, and then a C, a D. Okay, so it's look like you do a cross multiply, you see. So your AD minus BC, it is a what? A 2 and a 1. And then you do another cross multiply, but with a negative 1 and a 3. Okay, so you got negative 1 is not 0. So it means that your A inverse exists, okay, for this example. And your A inverse is just simply 1 over AD minus BC, which is negative 1. And then you are going to switch the position between your A and your D along the main diagonal. So you have 1 and 2 switched. And then here you put at the same position but with a different sign, right? So it is negative 3 and negative 1. Or, I mean, upon you multiply here, you have negative 1, 3, 1, and negative 2 as a result. Okay, here is your A inverse, okay, of this example. All right, and this one, if your A inverse exists, then it means that your A is non-singular. Okay, your A is non-singular. And if you want, then you can also check by multiply these two matrices. Okay, for example, this one is negative 2, here is 3, so negative 2 plus 3, you got a 1 here. And there, I mean, if you multiply it with your second column, so you got a 6, you see 2 and 3, you have 6, and then you 3 and negative 2, you got a negative 6, so together you have a 0. Okay, so if you do your second row and your first column, you have 1 and negative 1, which is negative 1, and 1 and 1, so you have 1, negative 1 plus 1, you have a 0 right here. And then the last one, if you look at the second column, so you have a 3 minus a 2, so 3 and minus 2, you have another one here, which is your I2. Okay, and then you can also look at the one that you interchange the order of your A and A inverse. Okay, just like that. So this one is A inverse times A. It also becomes your identity I2. So if you want to use the inverse to solve the system of the equation, so it's given that your system is AX equals to B. Okay, the first thing is that you need to have a number of equations and a number of unknown to be equal, okay, to be the same. So it means that your A must be square. Okay, like I told you that if we talk about the inverse, your A must be square at the first place. And then the coefficient matrix, so it means A is invertible, so it means that your matrix A right here, you need to be able to find your A inverse. Okay, the A inverse exists. Then you are going to do the multiplication both sides. Okay, so this one you are going to multiply by A inverse, and you're going to multiply by A inverse here, and you need to do it right here at the left hand side of your A, because as we mentioned a lot before, that the matrix cannot be, the matrix multiplication is not commutative, so you cannot switch the order of your multiplication. So you need to really have your A inverse attached with your A in order to go back to the identity. Okay, you cannot switch anything. And this one as well, you need to put it on your left of your B, the A inverse. Okay, and this one becomes just the X after you multiply by the identity. So it means that your solution is simply the X equals the A inverse multiplied by B. Okay, and if this one is invertible, of course, I mean the system has only a unique solution. okay, this solution. All right. So for example, I mean, if you want, but I don't want you guys to remember all this. I mean, if you can remember, it's okay. If you cannot, then we are going to just calculate it as numbers, okay, and then do a real multiply with your with a constant matrix on your right hand side, okay. So don't worry about this. This one is just the way we calculate it in terms of, you know, all parameters, okay. And if it is like more than 2, I mean, if it is greater than 2 by 2 matrix, okay, for example, it is like 3 by 3 matrices, okay, if it is 3 by 3 matrices, or something that it is greater than that. So what are we going to do? What are we going to do? We are going to find the inverse of a matrix. I mean, if, okay, if it exists, okay, if your A is invertible, by just write your matrix, okay, A in an augmented matrix together, attached on the back with your identity I, okay. Of course, I mean, the A and the I must be the same size or the same order. So if your A is n by n, your I is also the n by n identity, okay. And you are going to try to perform the elementary operations until the matrix A is reduced to I, okay, and that I on the back will becomes your A inverse, okay, will become your A inverse. All right. And I mean, if your A is invertible, okay, this one always reduced to the I, always, okay. But if your A is not invertible, then this A may not be able to reduce to I. It may reduce to something else, okay. I mean, all the A's can be reduced, all right. I mean, each and every matrix A can be reduced. But if your A is invertible, it will reduce to the identity. If not, then it reduces to something else. We get? All right. So this one, as I told you, is right here. And then if it's not reduced to the identity matrix I, it means that your A inverse does not exist and your A is a singular matrix. Okay. So let us show you one example, like the one that we just did before, the 2, 3, 1, 1. Okay, so if your A is 2, 3, 1, 1, and you need to find your A inverse, okay, so all what you need to do is to attach your A with your I2 as the augmented matrix, okay, and you guys must be patient because this one will involve a long process of the calculation. Okay, so here, I mean, the first one, you are, as I told you, to reduce a matrix, you need to sweep it by a column. But when you do it, I mean, when you calculate, you need to calculate it in terms of row. Okay, so as you look at your first column, you need to concentrate on your first position of the first column, and it must be 1. I mean, if it's not 0 at the first place, if it's 0, then you do switching, right? If it's not 0 at the first place, it must be equals to 1. So to do that, you just simply change your R1, so I'll write this way, into your half of R1, so that this one becomes a 1, 3 over 2, 1 half, a 0, a 1 again. I mean, the rest of your second row are the same, okay. We didn't touch your second row at all. And then after this one becomes a 1, then the rest in that column must be 0, so you need to get rid of this. And to get rid of this, I mean, when you still concentrate on your first column, you are going to use your first row to eliminate, okay? So it means that your first row stands still, but your second row only that change, and it changed by adding the opposite number of the one that you need to get rid of multiplied by your R1. So your first row, keep it. Your second row, if you do it right, then this one will be 0. I mean, this is just your second row minus your first row, right? So this one, it is 0. This one, 1 minus 3/2, so it is negative 1/2. And this one is 0 minus 1/2, so you have negative 1/2 again. And then the last one, it is 1 minus 0, so you have a 1, right? And then, I mean, this is done because you already have 1 at the beginning, okay, at the first position, and then the rest are 0. So the first column are done. Next, you are going to sweep to your second column, and then at your second column, you need to concentrate on your second position of the second column, okay, and it must be 1. So if it must be 1, then you are going to change it, okay? So your R2, you are going to multiply by negative 2, R2. So your R1 just remain the same, only your R2 does change, okay? So here's a 1, here's a 1, here's a negative 2, all right? So don't forget all the rest of your, I mean the whole row that you are going to multiply by negative 2, okay? Right now, after you got 1 here, then you need to get rid of the rest over there, right? So what is it that we do to get rid of the one above? So here your R1 is changed, okay, and it changed by using the R2 alone, okay? So your R1 that you need to get rid of is 3/2. So you are going to multiply by the opposite number with your R2, okay? So here it means that your R2 remain the same, okay? But this one you are going to multiply by negative 3/2. Don't forget that your first column is already done. It will be the same, okay? So if you multiply this one by negative 3/2 and then you just add your 3/2 there, it must be 0, okay? So I mean all these you really don't need to calculate, okay, for the first column and the second column, because if you did it right, then it must be 0. So the thing that you need to start to calculate is this one. So you multiply your 1 by negative 3/2, okay, negative 3/2, and then you add it by 1/2, okay? So negative 3/2 plus 1/2 becomes negative 1, okay? And here you have negative 2 multiplied by negative 3/2. So the negative 2 and the negative 2 cancel. So you have a 3. So it means that a 3 plus a 0, you have just a 3 like that. So here is your I2, there is your A inverse. So it means that your A inverse, it is negative 1, 3, 1, negative 2. Are they the same as what we did previously? You see, negative 1, 3, 1, negative 2. You see, negative 1, 3, 1, negative 2. So they are the same. They are the same. What if we need to solve, okay? So let's say that if we got 2x plus 3y equals to 1 and x plus y equals to 2, and you need to solve for x and y, okay? So it means that actually, what is your coefficient matrix? It is 2, 3, 1, 1, and your variable is x and y, and your constant matrix on your right hand side, it is 1 and 2. So here is ax equals to b, we get. So what you are going to do is that your x, I mean if if your A inverse exists, okay, I mean, does it exist? Of course, it's right here, right? Because your A, they are just the one that we calculate, okay? So your A inverse exists. So it means that your X becomes your A inverse multiplied by B. Your A inverse, it is this one. Your B, it is 1 and 2. So can you do a multiplication? So it is your first row multiplied by the column. So you are going to have -1 and 6. And your second row multiplied by the column. So you are going to have 1 and -4. And altogether you have a 5 and -3. So this one is your X, this one is your Y, the solution that you need, and it is a unique solution. Okay. Yeah. And I mean, if you don't like my handwriting, you can just look at the typing here. This is the same example that what we just did. Okay. Okay. So let us look at another example. Let me just do it with you guys. Okay. So if we are given your A to be 2, 4, 1, 2. Okay. So if you just do it as a previous A inverse, because this one is a 2 by 2, right? You can do the A inverse using the cross multiply first, is it? So here you are AD minus BC, it is 4 minus 4, which is 0. So what does this mean? Your A inverse does not exist. Okay. So this is your first way to do. However, we are going to do the other way as well, just to make yourself familiar, by attach your A with the identity I2. Okay. And then you are going to reduce. Okay. Oh, by the way, each reduction, I don't think it is good to write equal sign, sorry. So let me just use the arrow sign. Okay, each reduction changed by the arrow sign, like that. Okay, so this one, you are going to reduce it, right? So first thing, you sweep by column. Okay, look at the first column, and the first position of your first column, it must be 1. So you are going to, change your R1 into the half of your R1. So it will be 1, 2, 1/2, 0. Okay, you just simply divide it by 2 all the way, but your R2 remain the same. Okay, and then you are going to get rid of, or do the eliminate. Okay, to eliminate the other, okay, on that column, okay, which is right here, the 1. So you are going to do the R2 change into your R2, but then it use the R1 to change. Okay, so this one is 1, right? So the opposite number is simply a -1. So it means that your R1 remain the same. Your R2, of course, if you did it right, this one must be 0. And then the rest, I mean, from here, you just start calculating. So this is again your R2 subtracted by R1. Okay, so your 2 first minus 2, you have 0. Your 0 minus 1/2, so you have -1/2. And 1 minus 0, so you have a 1 here. Okay, so this one, I mean, after a reduction, this is done. This is already a reduced matrix. Okay, but this reduced matrix, it is not I2, and you cannot do any change into your I2, because I mean, for your second column, you don't have anything below the second position, right? Okay, so this is not the I2, so it means that your A inverse does not exist as well. Okay, and your A is singular. Okay, your A is singular. Are we all right? Again, if you don't like my handwriting, here it is the one that is typing pages. Okay, it's the same example. Let's look at another example. Okay, let us do it together. So if you're A, now it is a 3 by 3 matrix. It is a 1 1 1 1 and 1 0 negative 2 and 0 1 2, and you need to find your A inverse. You need to find your A inverse. Okay, so you cannot, I mean, you don't have any other option but using the raw operation. Okay, because if you are in 2 by 2 matrix, you still have some option to use either, you know, that fixed formula or the raw operation. But this one, a 3 by 3 matrix, you cannot do anything but attach it with your I3. So this one, so it is 1 0 0 0 1 0 0 0 1. Okay, and again, be patient, it will be a long process. So look at your first column, first position is already 1, so it's good. Then you just get rid of the rest, okay, rather than this first position, right? It must be all 0. So it means that you are going to change your R2 into your R2, and the opposite number of that thing, I mean the one that you are going to get rid of, multiplied by R1. Same thing apply with your R3. Okay, just multiply by the opposite number of this position with your R1. You see, you must keep it to be your R1. All right, okay, the one that you use it to change. Okay, so let's see whether we can squeeze it here or not. So your R1 are the same, okay, but your R2, I mean, as I told you, R2 and R3, if you did it right, it will be all gone. Okay, so let's see R2 minus R1. So your R2 first, R2 minus R1, so it's 0 minus 1, so you have negative 1. 1 minus 0, so you got 1, and 0 minus 1, so you have negative 1, and 1 minus 0, so you have 1 here, and the last one is 0 minus 0, so you still have a 0. Same thing apply to your R3. This one R3 minus R1, so your R3 first, so negative 2 minus 1, so you have negative 3. 2 minus 0, so you have a 2, and 0 minus 1, you got negative 1. 0 minus 0, so you have 0, and the last one, 1 minus 0, you got 1. Okay, now, I mean, the first column is done, so as you continue, the first column must be the same. You don't need to recalculate it. So you are going to sweep to your second column, and your second column, your second position of your second column must be 1. So you are going to change a little bit. Okay, your R2 becomes negative 1 R2, and then the rest are the same. So here is a 1, here is negative 1. Okay, just change your side of your R2. And now, okay, I mean, this is 1 already, so you need to get rid of the one above and the one below by using your R2. Okay, so it means that the one that you are going to change is your R1, right? The one on the top becomes your R1, and then the opposite number that you need to get rid of with your R2. Your R3 becomes your R3, and the opposite number that you need to get rid of and your R2. Okay, so let me squeeze it right here. So as I told you, this one, I mean, your R2 remain the same. The first column is already done, And if you did it right, the second column must be like this. Okay, it must be like that, right? So the one that you need to calculate is only this part. Okay, it's only this part. So the first one is easy. Your R1 minus your R2, right? Your R1 go first. So your R1, I mean 0 minus negative 1, you have a 1 here. And then 1 minus 1, you got a 0. And 0 minus negative 1, you have a 1 there. And 0 minus 0, you got a 0 there. Okay. And if you are R3, you need to add the 3 times R1. So you do a 3 times R2. So here is a negative 3, and then plus a 2, you got a negative 1, is it? Here is a 3, and then you add negative 1, so you have a 2. Here is a negative 3, you see, plus a 0, you have a negative 3. There is a 0 plus a 1, so you have a 1. Okay. Next, you are going to sweep to your a third column, and then again your third position of your third column must be 1. So you are going to do one more time. Your R3 becomes your negative 1 R3. So you are going to end up with this one are the same. Okay, the first and the second row are the same. Only this one must be 1, negative 2, 3, negative 1. Okay, and you are going to get rid of the rest above, okay, rather than this position. All right, so what is it that you will do? So it means that your R1 change again into your R1, and then add a negative number that you need to get rid of with the R3. You see, previously you do it with R2. So this one, because you looking at the third column, you do it with your R3 and your R2 as well. You add it with an opposite number that you need to get rid of with your R3. Okay. So here, I mean, your R3 remain the same. So you just copy it down. And the first column is already done. The second column is already done. And your third column, I mean, if you did it right, it must be like that. It will, I mean, all the thing will be 0. So the part that you need to calculate is only that part, okay? That part. So here, the first one is your R1 minus R3. So it's 0 minus negative 2, so you have 2. 1 minus 3, so you have negative 2. 0 minus negative 1, so you got a 1. And then this one, it is your simply R2 added R3, right? So you just add them up. So it is 1 and negative 2, negative 1. Negative 1 and 3, you have 2. And the last one, 0 and negative 1, you got negative 1. So there is your I3. Here is your A inverse. Okay. So let me compare whether I did it right or not. Okay. Let me just compare with the type, the one that we type it. So the first row, it is 2, negative 2, 1. The second row is negative 1, 2, negative 1. The third row is negative 2, 3, negative 1. Hey, we did it right. So that is that's your A inverse. Okay, that's your A inverse. However, this one, don't, what should I say? Don't think that the A inverse is pretty easy like this. Okay, usually the A inverse will involve a lot of fraction calculation. Okay, it usually will involve a lot of fractions. So in a real test or a quiz, okay, please be prepared that your A inverse may be, involve a lot of fraction calculations, okay? So that will be one of the thing that you may need to be careful. So let us try to ask you like this. If you got your x plus y equals to 1, your x plus z equals to -2, and your x minus 2y and 2z equals to 3, can you solve for x and y and z? Okay, can you solve for this? X, Y, Z? Of course, if you take a look at it carefully, then all the coefficient for your x, okay, it is all 1, the first row. And the coefficient of your y, it is 1, 0, -2. You see 0y here, okay, because it has nothing. And then a coefficient of your z, it is 2, 0, 1, 2. You see, and then all the variable ordered by x, y, z like this, and then the constant on the right hand side over here. So here is your ax equals to b again. If your a is invertible, then your x can be written as a inverse times b, right? So is it invertible? So look at this a, are they the same? They are the same a as we did on top, right? And we know that a inverse is that matrix. So a inverse exists. So it means that your x is simply your a inverse. Okay, you just copy your a inverse, multiply by your b. Okay, so just review on your multiplication. So the first row multiply with your column over there. So you have 2 and 1. You got -2 and -2. You got 1 and 3. All right. And then for your second one, this one, -1 and 1. So you have -1. You have 2 and -2. So you have -4. And -1 and 3. So you have -3. And the last one, -2 and 1. So you got -2 and 3 and -2. So you have -6. And -1 and 3. So you got -3. All right. So what you end up with on the first one is 2 plus 4 and a 3. So it is a 9. The second one, it is the -8, and the last one, it is -11. So here is your x, y, and z that satisfy this equation, this system of equation. Okay, so here's the solution, and it is of course unique. You see, so here's how we use the inverse, okay, to solve the system of equations. Okay, all right. Okay, so this is, like I told you, here is the typing version of that example, the same example that we did. Okay, so if you don't like my handwriting, you just keep looking at the one that's typed pretty neat, right here. So we are going to stop our clip at this point first, okay, and let you just, you know, digest what we have, and also try to make yourself familiar with all the, you know, row operation and how to find the A inverse. Okay, and we're going to continue next time. We'll see you. Bye bye.